Today, we're diving into one of the most controversial claims in AI, 100% accuracy. A CEO of a company claims they have achieved perfect accuracy for AI on enterprise data. In this video, I will share my interview with Tanmai Gopal, the CEO of PromptQL. This video is for everyone working with AI. Whether you're a developer, business leader, data scientist, or product manager interested in AI accuracy, you will understand what's really possible and what's marketing hype. We will explore how accuracy is measured in AI systems, get to the bottom of PromptQL's specific approach, understand why the AI community is skeptical of perfect accuracy claims, and learn how to evaluate such claims critically. Watch this video to the end to make informed decisions about AI implementations, as I will share a useful framework that will help you assess AI accuracy claims. Stay tuned. 100% accuracy in AI means that every single prediction or output the system makes is correct. Professional AI practitioners know that claims of perfect accuracy usually indicate either extremely limited testing conditions, misunderstanding of what's being measured, marketing overreach, or actual errors in testing. PromptQL claims to achieve 100% accuracy not just on benchmarks, but as a general capability on enterprise data. Their initial validation comes from the Frames benchmark with 10 complex questions, where they achieved 100% accuracy compared to 40% for traditional RAG approaches. However, they position this as evidence for a broader capability, saying their architecture provides a clear path to reaching 100% accuracy for enterprise data scenarios. The AI community has established multiple metrics beyond simple accuracy: precision, how many positive predictions were actually correct; recall, how many actual positives were found; F1 score, balancing precision and recall; and AUC ROC, performance across different thresholds. But there is the critical insight. These mathematical metrics often miss what actually matters in business. A system might have perfect mathematical accuracy, but fail to solve real business problems. This is why the industry is moving towards Evals, evaluation frameworks that judge whether AI outputs achieve business objectives, not just mathematical correctness. Before we dive into the interview with Tanmai, let's understand what PromptQL actually does. PromptQL positions itself as a data agent specifically designed for enterprise AI applications where accuracy is critical. In most common ways to add business context to data, each time an LLM is used, we may lose accuracy because LLMs are non-deterministic. For example, with RAG, the LLM is involved in multiple non-deterministic steps that can compound errors. First, semantic search might retrieve partially relevant or not correct documents. Then the LLM has to read through all the retrieved chunks in its context window, where it can misread facts, confuse numbers from different sections, or blend information incorrectly. For complex queries, RAG might need multiple rounds. PromptQL takes a user input, user prompt, and converts it into a domain-specific language that matches your exact business terminology. It can be medical procedures, financial compliance terms, or sales methodologies. The key is their dual-layer architecture. The LLM only makes a query plan using your business vocabulary. Then PromptQL executes that plan as deterministic code outside of the LLM context window. This means that when the doctor asks which patients had procedures last quarter, the system uses the LLM just once to understand the intent and create a plan, but then executes that plan programmatically, looking up the exact procedure codes, querying the database deterministically, and returning results without any probabilistic guessing. So by limiting the LLM's role to planning rather than execution, and by allowing businesses to define their own domain through metadata, through graphs, they reduce the compounding errors that can happen when LLMs are involved in every step of data retrieval and processing. So this architectural choice is fundamental to PromptQL's accuracy claims. Fewer LLM touchpoints means fewer opportunities for non-deterministic errors. So now let's hear the interview with Tanmai. After the interview, I will share the framework to help you assess AI accuracy claims and know what you can really expect. As you've mentioned in some of your blog posts, the biggest challenge is ensuring data accuracy. And trust and reliability is very important for the business.
Yep.
And you claim that PromptQL achieves 100% accuracy on enterprise data, which is a very bold statement. I think it's a little bit more nuanced. So maybe you can talk about what does that mean?
Yeah. It's a provocative statement to kind of pull you in, but what we have achieved, I would say, is 100% repeatability. So that means that if you ask AI something about your data, something that is very nuanced, has a lot of context, the same question and the same intent is repeatably converted into the same thing. So it does the same thing every single time. And that's a huge unlock, because now if you can make it do the right thing, you suddenly achieved a path to 100% reliability, to full reliability, right? The worst thing is you ask a question today and it does something, and then you ask the same question tomorrow and it does something totally different. And you're like, how can I even trust you, right? You go to Gemini on Gmail and you ask it a simple question, right? Like, how much did I spend on Uber last month? Just refresh the page and ask it the same question again, different answer. Every single time it's a different answer. Every single time it's looking at different data. And this is very frustrating for an end user, because think about it, right? If you're working with a colleague, even if the colleague is not the best person, at least if the colleague does the same thing every single time, it's so much easier to trust the colleague, right? You're like, I can trust you. Like, it's okay. I know you'll screw this up. It's fine. But we have trust because I know what you'll screw up and I know what you won't screw up, right? Mm-hmm. Today's problem is that this colleague is hyper intelligent at something and then sucks at something else, and you don't even know why. Right? Failure is not predictable, and that is causing a lack of trust. Right. So what we've cracked is 100% repeatability. And now as you improve the planning accuracy, your accuracy starts going up dramatically, right? And so we in practice have seen well over 90% accuracy on real things repeatably and easily, going over to 95, 98% for depending on what domains there are and how much time we spend with the customer, etc., stuff like that. So that's the...
As I understand, when a user creates a prompt, it gets converted into a domain-specific language.
Correct.
It runs outside of the LLM's context. So what exactly is happening under the hood of that?
Yeah.
Is it a translator for the prompt to run deterministic code?
Got it. That's a very good question. So our background as a team is we're programming language theory people. So we're language nerds basically, right? Our team is people who've built languages and open source languages and stuff like that, right? So that's so we like to think of everything in terms of languages. And so when we looked at LLMs and the lack of reliability, we thought the problem is not that the LLM cannot speak in the problem is not that the LLM is not reliable. The problem is LLMs don't speak in the query language of your business. The first thing that we do is we teach the LLM to, instead of outputting English, we ask it to start outputting a new language that we teach it that is custom to your business. So let's say your business is called Acme. So we then output a language called Acme QL. So instead of outputting English or code or SQL, it now starts outputting AcmeQL. And AcmeQL is a proprietary language that we've created, which is essentially a language that can represent arbitrarily complicated plans. So an AcmeQL plan can say something like, oh, fetch enterprise users who have this characteristic, and then go look at their support tickets and see if they're feeling happy or not. And then go call this image model to generate an image like this, which brings in a little more repeatability into image generation. Not fully, but a lot more repeatability because you're giving it the same context every single time. So at least it's creative in the right ways, not the wrong ways, right? So these AcmeQL plans can represent arbitrarily complicated things. Now, the cool thing about an AcmeQL plan is that this plan can also be compiled into something that runs on a machine on a CPU. And so the LLM generates a plan, and then we take that plan, think of it as like we compile that into code, and then we run the code somewhere else. But now once you create the plan, the code is repeatable. You can keep, it will never change, right? If you get the same plan, you get the same code. This is what gives us repeatability, right? This is what gives the user a lot of confidence, because the user not just has to understand the plan, and a non-technical user can easily understand the plan. They're like, oh yeah, you looked at Salesforce, and then you looked at this data, and then you looked at that data. That makes sense. And then you searched like this. Okay, cool. I'm good. I don't need to look at code. I don't need to understand what you're doing. I get the feel of the plan. And once I trust the plan, it's guaranteed to compile into code that does exactly what the plan said and then execute that.
What happens when business gets new dimensions of data where that
plan doesn't apply anymore?
Yeah.
Things like that. Exactly. And that is the second piece of this, which is the teaching of the LLM. So which is why we can't teach the LLM our language. So we don't teach LLMs PromptQL. What we teach them is AcmeQL. So, let's say you're like Apple, so AppleQL, or let's say you're Meta, so MetaQL, right? So there is a learning layer. And what this does is it learns from the semantics of your data, and it learns from conversations that are actually happening in the system. It takes that as input to learn and to teach the LLM your language. So the first time you run our system, it only knows PromptQL. But then gradually, PromptQL becomes your QL, right? Yeah. It becomes that. Because, so for example, it goes from, tell me the patient readmission rates for DRG 470. What even, right? Like, what is this? What is this question?
Yes.
So PromptQL will struggle. It will spend a lot of time trying to find out that information. But once it does, the next week when you open it, it'll get it immediately, because it's learned how the plan navigated data, whether it does structured or unstructured things, and it feeds. So the learning layer is really important to make it your language. Otherwise, it's still our language, which is the whole point. It can't be our language. Our language will never be reliable.
What happens when at that first step, LLM misunderstands user intent?
Yeah. So you treat it like a colleague on day zero. So suppose you hired a colleague who's like the smartest analyst or the smartest engineer in the world, but they joined your company and you ask them this question: what are the patient readmission rates for DRG 470? And this is like, I have no idea what you just said, but I'm smart. Let me spend a lot of time to figure that out. So PromptQL does the equivalent of like a deep research. Mm-hmm. So it goes into all of the data, samples them, tries to figure it out. It takes instructions from you. So it'll take very precise instructions from you and you can say, what I mean by patient readmission rates is this is how you calculate it. And what I mean by DRG 470 is go look up that data here and extract that code from the comment.
So it comes back to you with clarifications?
It comes back to you with clarifications. Mm-hmm. It comes back doing a lot of research and saying, I kind of found something relevant, but you'll have to tell me a little bit more about where to look, because there's too much to look at. I don't know. So you guide it. Just like you would guide your colleague on day zero, you would onboard them. Mm-hmm. So you give them small tasks to help them learn about your business. But then 1 week later, they already know, right? Now they've learned this. Now they've captured it in their kind of brains. In our case, they've captured that in the semantic layer. Yeah. And so now it knows. Now you ask it that question, it's like, cool, I know what to do. I remember from last time I saw the plan. Yeah. And now I know what the semantics are. I know that there are new columns. I know that this data contains this. And I know that the typical way of calculating readmission rates is to do A, B, C, D. That's the algorithm. So it knows that. And the next time it'll just use it.
So far, we have the names for everything, like RAG, fine-tuning, different 100 variations of that. What's the name that you're using to describe this in like a 2-word, 3-word phrase?
That's a good point. So depending on who we talk to, we help ground it to something that's unique to them. But what we call it in a thing is we say that it's a language. It's the language of your business that we teach LLMs to speak. So we teach LLMs to speak the language of your business. That's the way we describe this technique at an abstract level. But very specifically, when people kind of look into like if you, for example, are a person who's doing RAG or semantic layer kind of stuff, we then kind of connect it to your techniques and say, imagine if your semantic layer was agentic. Imagine that instead of you maintaining the semantic layer, there was an AI whose one job was to just maintain and learn the semantic layer, was to look at conversations and then just build that. Or if we're talking to knowledge graph people, then we kind of tell people that it's like, think of it as like a semantic graph instead of just a knowledge graph. Think of it as a knowledge graph being updated continuously because a knowledge graph is static, it's brittle, right? So in this case, it's like the knowledge graph is updating on its own. Think of that kind of like an autonomous or a semantic knowledge graph that is updating by itself. So we kind of add the word agentic or autonomous to help people understand. But I do think that by the end of this year or early next year, we'll have the terms to kind of talk about techniques where you start teaching LLMs the language of your business. If you're looking at all the material that's coming out from the frontier labs, they're all kind of talking about the fact that, look, AI is probably going to do everything except for the stuff that's unique to your business. And so how you teach it what is unique to your business, that's going to be the main thing.
What if somebody tomorrow creates the same technique and renames it to something else? Like, how do you stay competitive in this industry?
That's a very, very good question. I think there's a compounding effect. I think today the knowledge that we have on how to teach LLMs your language of your business, nobody knows this already. Like, this sounds simple. It sounds obvious, but when you do it, it's actually very hard. The way, how do we capture those learnings? How do we capture procedural semantics? Like readmission rates, it's not a schema definition, right?
So that is expertise related, right? Like
capture the AI that can capture this expertise and represent it.
Yes.
This is IP that is like people have to figure out how to do it.
Right.
Then how do you teach that to the LLM? Are you going to do in-context learning? Are you going to prompt engineer it? Are you going to fine-tune it? Are you going to do post-training? What are you going to do, right? We do all three. Depending on the complexity of your language, we choose between one of these three methods. So there is kind of a compounding of IP that happens as people do this. So I think when 6 to 12 months later, this is going to become the default technique. But by that time, we will be far ahead.
So you will gain a lot of trust because you are the first one to actually execute on this.
Exactly. And that's what's happening. Like if you, one of the largest tech companies is a customer, one of the largest restaurant brands in the world is a customer. And literally, if you look at their quotes, they're like, we've tried 100 different vendors to do Q&A on enterprise data. We've looked at 100. We tried 20 on our data. This is the first thing that works, right?
This is cool.
And so we're looking at like deals that are 7-figure size deals that we're closing in less than 2 to 3 months.
LLMs are obviously not perfect yet. And human in the loop is needed. And techniques like interrupting the, the execution. I guess in your case, because you're actually deterministic execution, you do not need to do that.
Those become very easy problems to solve. So, for example, what our runtime that executes the language, right? We call it like Acme QL or like Lena QL or whatever, right? Like it'd be your company's language. In that case, like the part, because we know exactly what it's doing when it's accessing data, every time we detect that it's a write operation, we do an interrupt. So if it's a write operation, we can interrupt it and force a human in the loop, which you can turn off if you want. But we have a very fine amount of technical clarity on every single operation that's happening. So every time the LLM runs, you can actually look at a trace output, whether it's Datadog or whatever, or our default trace. You get a detailed trace of every single data piece that it's pulled, where it's gone to, and it applies these authorization rules that determine who gets access. So one of the kind of critical parts of this idea is that the code that is being written, it's not running in system space. It's running in user space. So that means if you're using our PromptQL platform and when you're writing instructions in Lena QL is running with your identity. It's not running as privileged code. So no matter what you do, you cannot pull out somebody else's data. You cannot act on somebody else's data. You can't screw things up for somebody like that you're not supposed to. You can ask and prompt engineer it to like how to build a nuclear bomb, but you can't get somebody else's data. Do you know what I mean? Like LLM safety is still a problem because you can crack LLMs, but data safety, transaction safety, that's not an issue.
As you've heard, Tanmai provided more realistic numbers for actual enterprise deployments. They're achieving closer to over 90% accuracy with their enterprise data. And he also confirmed that the execution portion of their flow is deterministic, which is important to understand. Now, I want to share a nuance that often gets missed. Traditional metrics like accuracy, precision, and recall are mathematical measures that fundamentally lack business context. This is the critical gap in how we evaluate AI systems. A system that achieves good mathematical accuracy may still completely fail at solving actual business problems. This is why evals, which are evaluation frameworks with pass-fail criteria, have become the gold standard for assessing AI in business contexts. Evals answer the only question that really matters. Does this AI output achieve the business objective? So let me explain how evals work. With human-graded evals, subject matter experts review AI outputs and mark them as pass or fail based on real business criteria. They ask questions like, does this customer service response actually resolve the issue? Would this financial analysis lead to the correct investment decision? Would a human expert approve this output for production use? And human grading captures these nuances that mathematical metrics cannot measure. It tells us whether the AI understood context, applied appropriate judgment, and delivered real value. There is also LLM as judge evals, where we use another AI model to evaluate outputs at scale. This provides consistent evaluation criteria across thousands of tests and scales beyond what human reviewers can handle. But it still requires human validation of the judging criteria. Leading AI companies like Anthropic and OpenAI are actively using eval-based assessments. They create test cases that represent real business scenarios and then measure pass rates. The gap between mathematical accuracy and business effectiveness is where most AI systems reveal their true limitations. So, how should you evaluate AI accuracy claims? There is a simple framework that will help you assess any AI solution's performance claims. First, let's examine the testing methodology. How many test cases were used? What was the test data? Was it representative of real-world scenarios? Were edge cases included? How long was the testing period? Was there independent verification? Then let's look at real-world performance data. What accuracy do actual customers achieve? How does data performance vary across different use cases? What happens when accuracy drops? How does the system handle errors? Then we need to look at our evals-based evidence. What was the pass rate on business relevant scenarios, not just mathematical accuracy? Are there human-validated results showing actual business value? Then we need to consider the business implications. What is the cost of the errors in your specific use case? Can you create your own evals for pilot testing? Can the tools actually guarantee performance based on your evals? How does the system alert you when the confidence is low? Now you understand the reality behind accuracy claims in AI. When implementing AI, set realistic accuracy targets based on your use cases. Design eval frameworks that measure actual business outcomes, not just mathematical correctness. Create pass-fail tests for your real business scenarios. Use both human graders and LLM as a judge to have comprehensive coverage. Test edge cases and unusual situations, and measure what matters to your business. Things like customer satisfaction, revenue impact, risk mitigation, things like that. Implement comprehensive monitoring that tracks eval pass rates over time. Watch for degradation in specific scenarios. Set up alerts for drops in business metrics, and plan for regular model updates as your business evolves. And always enable human oversight for critical decisions, with fallback mechanisms for when AI fails. The real value of AI is about building systems that consistently pass business-relevant evals while being transparent about limitations. Make sure to like this video and subscribe to the channel. See you in the next video.
Your reality has changed. You're stuck in your career. You're either using AI or being used. Do you still believe success is guaranteed? You feel it's time to wake up. Old strategies don't work anymore. Welcome to the real world. It will never be the same again. You need to fight for your future. Learn to spot truth from lies. I will help you. Together, we will win.